We've talked about null and alternative hypothesis. The homework we just turned in was talking about the hypothesis testing for p hat, which is the one I have on the board. And then we were talking about, in this last section, hypothesis testing for a mean. The difference is when you're dealing with the mean, that's when we have the condition. Instead of n times p times 1 minus p, we just either have to know the data is normal or it has to be bigger than 30. And you're using the t distribution instead of the z when you read probabilities from the table. Remember I talked about, we did the classical approach, the p-value approach, and we realized that neither one of those was super accurate because the t table does not give us all the probabilities. And so we kind of concluded that our best option on those is the calculator for most of those. So I may ask you to do one by hand. You should make sure you know how, but the majority of these we're just going to do on the calculator. Remember, that's if you go to stat tests. If you're dealing with the population mean, you're looking at number 2, the t test. If it was the proportion, which one would you use? The z, yeah, the one proportion z test. I thought somebody said B, and I was like,
B.
Is it number 5?
Wait, what class is that? Is that pre-calc? Dude, I don't know what I'm talking about. I'm sorry.
Is it number 5?
yes, number 5.
Yeah, number 5
Okay. So, the last thing I want to talk about on this section is sometimes you might get that we reject the null, but it's not really useful. This can happen if you have a really large sample size. You could get a significant result, but it's not a practical significance. You know, it might be the difference between me saying something takes 60 minutes and 61 minutes. Is there really all that much difference? No, it might be significant, but not practically significant. So I wanted to show you an example where that happened, and this will kind of refresh how we do this one. The last example we did Friday, I did both by hand and on the calculator, so this one I'm probably just going to do on the calculator. So in 2003, the average age of a mother at the time of her first childbirth was 25.2. To determine if that has increased, a random sample of 1,200 mothers is taken and is found to have a sample mean age of 25.5 with standard deviation 4.8. Determine whether the mean has increased using alpha equals 0.05. Okay, first thing, no matter if we're talking about the hypothesis testing for the mean or the population proportion, we have to check our conditions. We are talking about the sample mean here because we're talking about average age. What is the condition that has to be true here? What's our criteria?
In the null hypothesis, p equals 25.2.
Yeah, but before I can even do that, what's the thing I have to check to see if it's even okay?
Just see if it's the population is less than 5%, and if n times p times 1 minus p is greater than 10.
Yes. Well, that's if the p, if we're talking about p. When it's the mean,
And it's greater than 30.
right, I either need it the data to be normal or my n to be greater than 30. So I have 1,200, which is most definitely bigger than 30. So that's the piece that tells me it is normal, which tells me I can do all the other stuff I need. We had that one scenario where it wasn't normal and we had to use the binomial distribution to do it. So it is important to check this. Then we do our null and our alternative. Our parameter, the thing we're testing here, is the average, so the mean, so we're going to use mu. Null is always mu equals something, and that would be 25.2. Alternative, we want to see if it has increased, so our mean is greater than 25.2. All right, from here, if I asked you to calculate your t-value, you could. We're going to do it on the calculator here in a second, but do you guys remember how you calculate the t? You have to do your observed mean, so your 25.2 minus the mean, or sorry, 25.5 minus the mean we're testing, 25.2, over our standard deviation, which remember to find standard deviation for these, you have to do the standard deviation given over the square root of n. And I'm having you test this just so on your homework when you get ready, when it asks you to calculate your t, you know how. So I get my standard deviation to be 0.138564. Alright, and then you could calculate your t, and you get 2.165. If I wanted you to use the table, how many degrees of freedom would we have? How do you find degrees of freedom? Right, it's n minus 1, so it'd be 1,199. Does our table even go that? No. So the table is definitely not going to be very accurate here. Let's do it on the calculator. So you go to stat, test, number 2, t-test. Our input should be stats. Our mean is the mu sub 0, 25.2. The x bar is the mean we observed. Sorry, that's 25.5 for the x bar. Our standard deviation, that's the standard deviation given in the problem, so that's 4.8. So I'll write this out so you can confirm that you're putting it all in correctly. The n is 1,200. Our test, we are doing greater than. And then if you calculate, it tells you, do you get the same t-value we had found? 2.165. If you're finding the t on the calculator, I would like for you to just jot that down just so I know that where you got it. And then it tells me our p, the probability is 0.015. Okay, how do we know if we reject or not?
If it is less than.
Right. What was my alpha?
0.15.
So my p is smaller than my alpha, which means we reject the null hypothesis. Okay, so what this is telling us is if we tested this, we can say that the mean age has increased. Now, practically, is there a big difference in saying the average age is 25.2 versus saying it's 25.5? No, you're still talking about a 25-year-old woman. You're talking about months, just a matter of months difference. So we found it statistically significant, but practically it doesn't really matter. So that's what it means if it's not practically significant. There's a difference, but it's not significant.
Like we reject them all, but it's not practically significant. Is that what
Yeah.
it says?
Yes. So we reject the null, but there is no practical difference between 25.2 and 25.5 when we're talking about age. So it was statistically significant, but if we're thinking about it in practical terms, it wouldn't matter. Any questions? Yes, ma'am.
Calculated the t sub 0.
Uh-huh.
How did we take the standard deviation divided by the
I did
square
it.
root of n?
I did it right here, and that's where I got that number.
Alright.
Other questions? So the rest of the time you have to work on your assignment. I would recommend maybe doing the first one. It has you do like the critical or the classical method. You might make sure you can do 1 or 2 of these by hand, but then you're probably going to want to use the calculator for the rest because we know the by hand method is not as accurate as the calculator.